Next up on the list is Asif, talking about investigating Windows Subsystem for Linux endpoints. So again, there's kind of a Linux theme here in this little chunk of slots here, which has been a common request. People want more exposure and information about Linux. So we have these two back-to-back talks here. So welcome, Asif, and take it over.
Thank you very much, Brian. Good afternoon. My name is Asif Matadar, and the title of my talk is Investigating WSL Endpoints. I'm a Director of Endpoint Detection and Response at Tanium. I've worked in InfoSec for over a decade, and specifically incident response and penetration testing for over 9 years, leading high-profile cases around the world, such as advanced targeted attacks, nation-state attacks, and data breaches. I'm an international public speaker where I've spoken at industry-recognized conferences in relation to innovative research I've encountered. This is my 4th year speaking at OSDFCon, and I'm quite humbled for my presentations to be accepted by the DFIR community, so thank you all. My research areas are in memory analysis and automation, NICS-based forensics, cloud forensics, and triage analysis. So Windows Subsystem for Linux was announced back in 2016, and ever since then, the industry has been taking advantage of what WSL has to offer. What does that mean for someone who works as a digital forensics and incident response professional? Well, adversaries and malware authors have already started focusing their attention on WSL, so it is important to understand the architecture changes. This talk will highlight the nuances from a digital forensics and incident response perspective and identify the various attack surfaces that an adversary can leverage, and when the need arises, the forensic artifacts of interest on a WSL endpoint. This is the agenda for the talk. I'll discuss what WSL2 is. What does that mean for digital forensics and incident response professionals? I'll highlight the 11 techniques that I've discovered from an adversarial perspective and the forensic artifacts to keep in mind. What is WSL2? It's a full system call compatibility, which means that WSL2 has its own customized kernel specifically for WSL2. So apps such as Docker are now supported. Whereas WSL1 had a translation layer to interpret system calls that allows them to work on the Windows NT kernel. This is challenging to implement all of the system calls for Linux binaries, especially for long-term support. Compared to WSL1, it is much faster, and WSL2 now has support for raw sockets. It's a new architecture for Windows Subsystem for Linux to run ELF64 Linux binaries on Windows. In-house kernel developed from stable branch at kernel.org. Customized kernel specifically for WSL2, which is optimized for size and performance. Kernel updates will be surfaced by Windows Updates. So it's a lightweight utility VM, not a traditional virtual machine. It's a thin version of a Hyper-V hypervisor, which has much faster boot times compared to traditional virtual machines. So there's no virtual machine configuration or management. The hypervisor is similar to what is used by Windows Sandbox. So Linux and Windows share the same timers, which means that Linux files can be hosted in a virtual disk with a Linux native ext4 file system using the 9P protocol to interact with Windows and Linux. So what does that mean for digital forensics and incident response professionals? Well, as I've mentioned, WSL2 has its own customized kernel specifically for WSL2, full system call compatibility. The ext4 virtual disk is on the NTFS file system in users app data local packages folder with the corresponding references to the instance name. In this example, Canonical Group Limited, which is Ubuntu. Management of WSL can be used to interact with WSL Hyper-V VMs. So you can import and export distributions. You can set default distribution. You can also run them as version 1 or version 2. Environment variables are used on the WSL2 endpoints pertaining to the bash environment and the WSL environment variable that is used by the Hyper-V VMs. The Microsoft Store is where you're able to download the apps. As can be seen, I search for WSL and the Linux distributions that are available to download. Every app that you download creates the Windows Apps folder in the C program files Windows Apps, which is a protected folder that is hidden. Within the Windows Apps folder, each subsequent app has its own dedicated subfolder, and here you can see the Ubuntu binary, which when run will start the WSL2 Hyper-V. The other location is in the user's app data local folder, where there'll be a Windows Apps folder with the subfolders related to the designated Windows apps. Here you can see the Ubuntu binary in the user's app data local folder. With WSL2, it is now possible to access Linux files from Windows. It is similar to accessing a network resource, as the screenshots demonstrates the Linux distributions available to access. It is using the 9P protocol file server to facilitate file-related requests, with Windows acting as the client and WSL init daemon as the 9P protocol. Windows Terminal is the new command line experience on Windows that can be downloaded from Microsoft Store. Windows Terminal allows you to run PowerShell, Command Prompt, Linux distribution, and Azure CLI in one terminal with the ability to customize. So the Windows Terminal is not a new shell, but a UI on top of the existing one. As can be observed, when Windows Terminal is spawned, a child process called openconsole.exe is initiated, which according to Microsoft is the same source code as console Windows host, which is conhost.exe. Now I'll discuss the 11 techniques and the attack surface that an adversary can leverage, then analyze the WSL endpoint from a forensics perspective. This is the environment that was used. So Windows 10 Pro, version 2004, build 19041.84. These were the experiments that were run, and the premise being that the adversary has a foothold on the WSL endpoint, then leveraging the attack surface. I'm going to demonstrate the different attack surfaces from an adversarial perspective and the forensic artifacts to be aware of. The first technique I'll talk about is persistence using bash RC. As mentioned earlier, the environment variables for bash environment and the WSL environment variables are used on WSL2 endpoints, as is evident in the registry editor illustrated here. This is important to highlight because we will be making amendments of the bash environment for this persistence technique to work. In this example, we have a bash RC file appended with the awk reverse shell and the listener from the attacker perspective confirming that the shell was received, and it was indeed the customized kernel version of 4.19.84 developed by Microsoft. Something to note here is that after each time the WSL2 Hyper-V started, the persistence technique will run. From an analysis perspective on the WSL2 Hyper-V, it is important to trace the mat times and data contents of the bash RC file, along with the bash or shell history, including the inodes from a timeline perspective. There are a number of process execution artifacts to keep in mind on WSL2 on Windows 10 machines. The amcache file is a registry file that stores the information of executed applications. That includes the execution path, the first installation time, first executed time. And here it's evident that the amcache program entries, along with the amcache associated file entries, can be traced. The application compatibility database is used to identify the application compatibility issues. So the shims allows backwards and forwards compatibility for applications on different software platforms. As is illustrated, the application compatibility database showed artifacts where the Ubuntu binary file was executed. Another useful artifact is the user assist that contains information pertaining to links and applications used frequently with count and last modified time. In this example, it is possible to ascertain how frequently the WSL2-V has been used along with the last modified time. The prefetch file is used for optimizing the load time for application for performance reasons, which can be used to ascertain when a binary or application was last executed, along with how many times the Ubuntu binary was identified as being executed. The MFT is a database in which the information about every file and folder is stored on NTFS. Parsing the MFT showed traces of a virtual hard disk and the location of the Ubuntu binary. Moving on from there, this technique is what I like to refer to as persistence through inception using systemd. The first stage of this technique was that a file was created in the var temporary directory, which was a socat reverse shell to the attacker infrastructure, then enabling and starting the systemd service. The adversary was able to receive a shell and confirm that it was indeed an Ubuntu WSL2-V, which is the customized kernel version 4.19.84. The second stage of this technique was that an entry into the current version run key was included, with the entry being the Ubuntu binary. After each boot of a Windows 10 host machine, the persistence was successfully loaded, and the WSL2-V would establish a socat reverse shell. Analyzing the systemd journals along with the systemd configuration files can provide insights for an investigator. The registry artifacts for any persistence techniques being used where the entry is set to the WSL2-V can also be quite useful. The other artifact that's quite useful is the shellbags registry keys stores, which stores the user preferences for GUI folder display within Windows Explorer. Any user activity on Windows Explorer that were opened and closed can be traced with the shellbags registry key. First and last interacted times are quite useful to observe. So if an adversary has browsed specific directories in the UNC for the WSL-V, then the shellbag history key can provide indications of such activity, as this screenshot demonstrates. This technique is related to persistence using the cron tab. Modifying the etc cron tab file, as the screenshot illustrates, by running a file called start in the temporary file system dev.shm, by running the tail file against the syslog to identify that the cron job was run and the adversary accepts the shell. From an analysis perspective, analyzing the process command line activity, shell history, the bash history, syslog, and cron logs can be quite useful. This technique was used to create a reverse shell using the Bourne shell. Here you can see the execution of Bourne shell to create a reverse shell, and the adversary acknowledges the shell by running uname-a and concatenate the etc lsb release file. From an analysis perspective, analyzing the shell history, bash history, the inodes for timeline analysis, process command line activity, process lineage, along with outbound communications of the Bourne shell process. This technique is related to execution of PowerShell to create a reverse shell. Running PowerShell scripts is another technique that is possible on WSL2 endpoints. In this example, execution of a PowerShell script to make a call to the attacker infrastructure and the shell was received, and confirms by running get alias PowerShell commandlet to retrieve the aliases for the current PowerShell session. From an analysis perspective, analyzing the bash history and inodes to undergo timelines is recommended. Looking at unusual PowerShell processes that are established and outbound communications should also be observed. This technique is execution of Python by downloading a file. So it's possible to download a file using Python with acknowledgement that the file has been downloaded. This screenshot illustrates this activity. From an analysis perspective, analyzing the bash history, shell history, and inodes is recommended. This technique is downloading a file in Python for how network traces can be used to extract such files. So you enable network traces by running netsh trace start with a packet filtering capability capture, then the source or destination IP address. You can see the file being downloaded using Python. When you stop tracing, an event tracelog, an ETL file is created. You can convert the network frames from the ETL file into a pcap-ng file to be analyzed with Wireshark, TCP-dump, or tshock. In this example, the Python file that was downloaded with the HTTP GET request and the user agent is apparent. Here you can see that the file it was possible to be able to extract the file. You can export the HTTP objects and save the file as highlighted here. This technique is going to be similar in nature, but will establish a SOCAT reverse shell and use network traces to analyze the packets. Network traces were started. After the network traces were started, a SOCAT reverse shell was established to the attacker infrastructure with the adversary acknowledging the shell. Network traces were stopped. Once the ETL file is converted into a pcap-ng file, you can see that the SOCAT reverse shell was established along with the attacker infrastructure IP address, the destination port, and the error that the TTY can't be accessed. The adversary ran uname-a, and the output of that is evident here. The adversary then ran ps-ef, as can be seen. This technique is in relation to execution of a WSL binary, where it is used to interact with the WSL Hyper-V VMs and setting default distributions, but an adversary can use the exec option to execute Linux commands. This example shows the exec option being used and running concatenate against the etc OS release file to retrieve a version of Linux. This example shows the exec option being used and concatenation of an etc shadow file. This example is showing the exec option being used and downloading an arbitrary file on the file system and confirming that the file is on the file system there. This is another example of the exec option being used, but this time to pipe commands. So to tar the file and pipe that into an SSH session without touching the known host file. It is clear that the known host file was not touched and the file was exfiltrated to the attacker infrastructure. From an analysis perspective, it is important to analyze any process command line activity, process lineage in relation to the WSL binary. There is one caveat here in that the Linux command will not be saved in bash history or shell history, etc. So it's very important to determine the above 2 points in relation to analyzing this technique. This technique is in relation to execution of a bash binary. The bash binary is located in C Windows System 32 on the endpoint. This is an illustration of execution of a bash command with OpenSSL to download an arbitrary file from the attacker infrastructure. From an analysis perspective, analyzing the process command line, execution of a bash binary, and outbound communication should be something to look out for. Finally, execution of a curl command. This example shows that the curl command was used to exfiltrate a file to the attacker infrastructure with a SOCAT listener, and it was possible for the file to be exfiltrated successfully. From an analysis perspective, analyzing the process command line, execution of a curl binary, and outbound and inbound communication should be observed. To conclude, adversaries will continue to explore attack surfaces on WSL2 endpoints. WSL2 endpoints is going to make digital forensics and incident response professionals' lives interesting, to say the least. I have highlighted 11 techniques based on my initial research, but I expect more techniques will be uncovered in the coming months and years as WSL2 becomes more prevalent. These are the references I use in this talk. Thank you for attending my talk, and I'd be happy to answer any questions.
Thank you very much for that. It's a lot of great information there on places that we can look for some other artifacts and evidence of persistence and various things. There's a bunch of questions on the Discord channel that I'm sure you can go answer and respond to. So thank you for that.